Assalamu alaikum wa rahmatullahi wa barakatuhu. My name is Divya Imtiaz and my topic of presentation assignment is boron nitride nanotubes, and my roll number is 2500914005. First of all, we will discuss about the introduction of boron nitride nanotubes. What are boron nitride nanotubes? First of all, we will discuss its intro. The rapid advancement of nanoscience and nanotechnology has led to the discovery and development of novel nanomaterials with extraordinary properties that differ significantly from their bulk counterparts. Among these materials, nanotubes have emerged as particularly important class due to their unique one-dimensional structure and remarkable physiochemical characteristics. While carbon nanotubes have dominated research there since their discovery by Ijima in 1991, alternative nanotubular materials such as boron nitride nanotubes have gained increasing attention. This figure shows carbon boron nitride nanotubes, and then we also discuss some past history about boron nitride nanotubes. Boron nitride nanotubes were first synthesized in 1995, shortly after the discovery of carbon nanotubes, and represent a structural analog in which carbon atoms are replaced by alternating boron and nitrogen atoms. This substitution results in profound differences in electronic structure, polarity, chemical stability, and interaction with external fields. Boron nitride nanotubes exhibit a superior thermal and chemical stability, oxidation resistance at high temperatures, and excellent mechanical properties, making them suitable for extreme environments where carbon nanotubes may fail. Then we will discuss about the structure and fundamental characteristics of boron nitride nanotubes. Boron nitride nanotubes consist of hexagonal boron nitride nanotube sheets rolled into seamless cylindrical structures. Each hexagon is composed of alternating boron and nitrogen atoms connected by strong covalent bonds. Due to difference in electronegativity between boron and nitrogen, boron nitride nanotubes possess partial ionic character, resulting in permanent electric dipole along the boron nitrogen bonds. Structurally, boron nitride nanotubes can be classified according to their chirality. Chirality means an object or molecules that are not superimposable on each other, as armchairs, zigzag, or chiral nanotubes. However, unlike carbon nanotubes, the electronic properties of boron nitride nanotubes are largely independent of chirality and tube diameter. Boron nitride nanotubes consistently exhibit a wide band gap of approximately 5.5 to 6.0 electron volt, classifying them as electrical insulators. Here are some examples. Here are some pictures of boron nitride nanotubes, carbon nanotubes, and silicon carbide nanotubes. It discusses about the structure of carbon nanotubes, and these images tells about carbon nanotubes and boron nitride nanotubes, and it shows it has a hexagonal structure in which carbon nanotubes only carbon atoms are present, while in carbon boron nitride nanotubes boron nitrogen and boron atoms that are alternately arranged. And silicon carbide, in silicon carbide carbon atoms, silicon atoms and carbon atoms are arranged hexagonically. These are some pictures and images of the carbon nanotubes, boron nitride nanotubes, and silicon nitride carbide nanotubes. Then we will discuss boron nitride nanotubes can exist as single-walled or multi-walled nanotubes. Multi-walled boron nitride nanotubes consist of multiple concentric boron nitride nanotube layers with interlayer spacing comparable to that of hexagonal boron nitride, approximately 0.33 nanometer. The strong in-plane covalent bonding and weak interlayer van der Waals interactions contribute to their high axial strength and flexibility. Then we can say that there are boron nitride nanotubes that can exist as single walled and multi walled nanotubes. But multi-walled nanotubes, boron nitride nanotubes consist of concentric layers with interlayer spacing as comparable to that of hexagonal boron nitride, while the strong in-phase covalent bonding and weak interlayer van der Waals interaction contribute to their high axial strength and flexibility. Synthesis method. Then we will discuss about the synthesis method of boron nitride nanotubes. In boron synthesis method of boron nitride nanotubes, the synthesis of high quality boron nitride nanotubes remains a significant scientific and technological challenge Several methods have been developed, each with specific advantages and limitations. We can say that every method has several advantages, specific advantages, and specific limitations during the manufacturing of boron nitride nanotubes. First, we will discuss about arc discharge method. What is arc discharge method? Arc discharge method is a method in which we study about how nanotubes, boron nitride nanotubes can be manufactured. We can also manufacture carbon nanotubes, but there are also some processes for manufacturing of carbon nanotubes. But in this process, we will discuss about manufacturing of boron nitride nanotubes. So we will discuss about arc discharge method. The arc discharge technique involves generating a high temperature plasma between boron containing electrodes in a nitrogen rich environment. We can say that there will be two electrodes with a in which there is a rich nitrogen environment, and there will be a high temperature. This method can produce boron nitride nanotubes with relatively high crystallinity. However, control over tube diameter, length, and purity is limited. The process also requires extreme conditions and yields low quantities. We can say that control over tube diameter and length and purity is limited, so that the process requires extreme conditions and it yields low quantities. Of discharge method, what are the advantages? The advantages of this process is that the main advantage of this process is that it produces high crystallinity boron nitride nanotubes with good structural quality, and boron nitride nanotubes have few defects and good mechanical strength. Limitations: there is a process which has advantages, it also have limitations as well as we can say that disadvantages. Now we will discuss about the limitations. There are some limitations of this process also. It requires very high temperature, 3000 to 4000 Kelvin. It gives low yield of boron nitride nanotubes as compared to other methods. It contains many impurities such as amorphous boron and catalyst particles. Next, we will discuss about the second method is laser ablation method. What is laser ablation method? In the laser ablation method, a high power laser is used to vaporize a boron containing target in the presence of nitrogen gas. We can say that there will be a boron containing target, which we will break down our we will break down with the help of our laser high power laser beam in the presence of nitrogen gas. This technique allows better control over synthesis conditions and produces high quality boron nitride nanotubes, but it is expensive and not suitable for large scale production. This method is good although, but it is expensive and suitable for large scale production. Advantages: every method has advantages as well as disadvantages. So first we will discuss about the advantages of this method. What are the advantages of laser ablation method? The laser ablation method has few advantages. The main advantage of this process is that it produces high purity and well aligned boron nitride nanotubes. It gives excellent crystallinity and uniform structure. Laser ablation method is although good and because it provides excellent crystallinity and uniform structure. Limitations: what are the limitations of laser ablation method? We will also discuss about it. Limitations of the laser ablation method is that it requires high powered laser system and it is very costly. It requires so much cost, and it is very costly. We maybe cannot afford it. It also gives low yield and not suitable for large scale production. It also gives a very little or low yield that is not suitable for large scale production. We can apply it only for at lower scale or the small scale production. For the small scale production we can use it. Chemical vapor deposition method. What is chemical vapor deposition method? Chemical vapor deposition method is one of the most promising methods for boron nitride synthesis. In this approach, boron containing precursors react with nitrogen or ammonia at elevated temperature in the presence of catalyst. That we can say that there are catalysts are present with nitrogen at high temperatures, and the boron containing precursors also present that react with nitrogen and ammonia at a high temperature in the presence of catalyst. CVD, chemical vapor deposition, offers better control over nanotubes growth, scalability, and integration with substrates, making it suitable for industrial applications. This method is good, and it also provides that nanotubes, boron nitride nanotubes with high crystallinity and high scalability, and gives good nanotubes growth. Advantages: what are the advantages of this method? Why we should use this method? It is one of the most promising method for large scale boron nitride nanotube production with better control over length, diameter, and morphology. This method has great advantage because boron nitride nanotube production with better growth, and it provides high crystallinity, and the morphological structure of the boron nanotubes are good. We can achieve boron nitride nanotubes with greater crystallinity rather than from other methods. Limitations: as all the processes have advantages as well as disadvantages. Now we will discuss about the limitations of chemical vapor deposition method. Boron nitride nanotubes may contain structural defects. This use of catalyst may introduce metal impurities. We can say that boron nitride nanotubes although provide boron nitride nanotubes with greater crystallinity, but maybe it may contain structural defects, and this use of catalyst may introduce metal impurities, and structural defects, and this use of catalyst may introduce, as there are also catalyst present that may cause impurities. That's why this will be the limitation of this method, chemical vapor deposition method. Ball milling and annealing: this is another method of making boron nitride nanotubes. Ball milling and annealing: what is ball milling and annealing? This method involves mechanical milling of boron powder followed by annealing in nitrogen or ammonia atmosphere. Although it is relatively simple and cost effective, the resulting boron nitride nanotubes often exhibit structural defects and lower purity compared to those produced by CVD or laser ablation method. This method as involve mechanical and milling of boron powder followed by annealing in a nitrogen or ammonia atmosphere, and it is simple, cost effective, and resulting boron nitride nanotubes often exhibit structural defects and lower purity compared to those produced by CVD or laser ablation method. Then we will discuss about advantages. It operates at relatively low temperature and pressure. It is usually with simple and low cost. We can say that this operates at very low temperature and it is simple and low cost. That's why this is the main advantage of this process. Limitations: then we will discuss about limitations. As all the processes have advantages as well as disadvantages, now we will discuss about the disadvantages of this process. It produces boron nitride nanotubes with lower crystallinity, and it is mostly useful for laboratory scale. Autoclave method: what is autoclave method? Autoclave method is another method of manufacturing boron nitride nanotubes, and this a solo thermal technique where boron precursors react with nitrogen sources in a sealed autoclave at high temperature and pressure, leading to the formation of boron nitride nanotubes with controlled morphology but relatively low yield. We can say that a technique in which the precursors can react with nitrogen sources, and it is completely sealed autoclave or machine. We can say that at high in which a high temperature and pressure is maintained for the formation of boron nitride nanotubes, and the all the conditions should be controlled. All this that will control morphology and formation of boron nitride nanotubes with controlled morphology, that it will provide the structure of with proper structure of the boron nitride nanotubes, but with relatively low yield. We cannot get high yield of boron nitride nanotubes through this process. There are some images of all the processes that we discussed earlier. There are some pictures that we discussed above: laser ablation, template, ball milling, CVD, arc discharge, and autoclave method, boron nitride nanotube synthesis methods. These are the some methods that we discussed above. Laser ablation method and CVD, chemical vapor deposition method, in which gas flows and furnace, and there are some catalysts used in arc discharge method, and gas inlet and deposition, precursor catalyst, and cathode and anode and electrode are used. The laser ablation method, laser ablation method, laser beam is used. Then we and target precursors are first converted into vapor phase to form boron nitride nanotubes. Ball milling and annealing, also another method that we already discussed above. Then the advantages: the main advantage of this process is that it requires lower synthesis temperature compared to arc and laser ablation method. It is usually simple and inexpensive equipment. This advantage of the this advantage of the mainly uh, autoclave method. In autoclave method, the main advantage of this process is that it requires lower synthesis temperature compared to arc and laser ablation method. It is really simple and inexpensive equipment. Then we will discuss about the limitations, as we already discussed all the processes and their advantages and disadvantages. So there are some limitations of this process also. Limitations: it produces boron nitride nanotubes with lower crystallinity. It is also not suitable for large optical industrial production. In this process, it may also contain impurities or mixed boron nitride phases. It is so we can say that because it produces low yield, and it is not applicable to obligated industrial production, and it because it may contains impurities or mixed boron and BN nitride phases. Then will discuss about comparison between boron nitride nanotubes and carbon nanotubes. We will discuss shortly main differences between boron nitride nanotubes and carbon nanotubes. First, we will discuss about the properties and what properties they differentiate from each other: boron nitride nanotubes and carbon nanotubes. Composition: we can say that what type of element they are composed: boron nitride nanotubes and carbon nanotubes. Boron nitride nanotubes composed of boron and nitrogen, whereas carbon nanotubes composed of carbon atoms only. Electrical behavior: boron nitride nanotubes are insulators, and they are metallic. Carbon nanotubes are metallic semiconducting, because boron nitride nanotubes are made up of nitrogen atoms, and they are non-conducting non-metals, and they are composed of carbon and nitrogen, but they are somehow metallic semiconducting. Electrical behavior: then we will discuss about thermal stability. Thermal stability of boron nitride nanotubes is very high as compared to carbon nanotubes. On the other hand, oxidation resistance of boron nitride nanotubes is excellent, whereas the carbon nanotubes are chirality dependent. Band gap is constant at 6 electron volt, whereas in carbon nanotubes it is lower. There is a picture that describes about boron nitride nanotubes and carbon nitride nanotubes. It basically shows that it is white, higher temperature, greater than 900 degree Celsius in air, electrical insulator, piezoelectric, and no absorption in visible spectrum, high neutron absorption, high strength, high stiffness, high thermal conductivity, and high aspect ratio and low density of boron nitride nanotubes. On the other hand, carbon nitride nanotubes are black, lower temperature 400 degrees Celsius in air, metallic or semiconducting. As we will discuss above their properties also. Then we will discuss about physical and chemical properties of boron nitride nanotubes. What are the mechanical properties? thermal properties, electrical properties, and optical properties, and chemical stability. Then we will discuss about characterization techniques, physical and chemical properties of boron nitride nanotubes, mechanical properties. Boron nitride nanotubes exhibit exceptional mechanical strength with a Young's modulus comparable to or even exceeding that of carbon nanotubes. Their high tensile strength and flexibility make them suitable as reinforcement materials in advanced composites. Thermal properties. One of the most remarkable features of boron nitride nanotubes is their outstanding and thermal stability. They remain structurally stable at temperatures exceeding 900 degrees Celsius in oxidative environments, significantly output performing carbon nanotubes. Boron nitride nanotubes also possess high thermal conductivity, making them attractive for thermal management applications. Electrical and optical properties. Boron nitride nanotubes are wide gap, band gap insulators with strong ultraviolet luminescence. Their optical properties are relatively insensitive to structural vibrations, which is advantageous for optoelectric devices. Additionally, boron nitride nanotubes exhibit piezoelectric behavior due to their polar boron nitrogen bonds. Here is a term we will study. We discuss piezoelectric effect behavior. This is the behavior when a solid generates electric voltage when a mechanical stress is applied and it deformed a bit. What piezoelectric behavior is a behavior in which a solid generates electric voltage when mechanical stress is applied and it conversely deform under electric field. Basically, it is a reverse effect. Then we will discuss about chemical stability. Chemical boron nitride nanotubes inert chemically inert and resistance to oxidation, acids and bases. This stability enables their use in harsh chemical and environmental conditions where other nanomaterials degrade. Then we will discuss about the characterization techniques. The characterization of boron nitride nanotubes required advanced analytical techniques, transmission electron microscopy. Then we will discuss about the characterization technique. The characterization of boron nitride nanotubes requires advanced analytical techniques. Transmission electron microscopy and scanning electron microscopy are used to study morphology and structure. X-ray diffraction provides information about crystallinity and phase purity. Raman spectroscopy and Fourier transform infrared spectroscopy are employed to analyze vibrational modes and chemical bonding. Thermal stability is commonly evaluated using thermogravimetric analysis. TGA. Applications of boron nitride nanotubes. We will discuss about what are the applications of boron nitride nanotubes. First, we will discuss about nanocomposites, then electronics and optoelectronics, energy and environmental applications, biomedical applications. First, we will discuss about nanocomposites. Boron nitride nanotubes are used as reinforcement fillers in polymers, ceramics, and metals to improve mechanical strength, thermal conductivity, and thermal stability. In electronics and optoelectronics, due to their insulating nature and UV emission, boron nitride nanotubes are explored for nanoelectronic devices, dielectric layers, and UV optoelectronic components. Energy and environmental applications. Boron nitride nanotubes show potential in hydrogen storage, energy conversion devices, and as protective coatings in harsh environment. Then biomedical applications. Functionalized boron nitride nanotubes have demonstrated promise in drug delivery, bioimaging, and cancer therapy due to their biocompatibility and ability to interact with biological systems. Challenges and limitations. What are the challenges and limitations of boron nitride nanotubes? We can say that despite their promising properties, several challenges hinder the widespread application of boron nitride nanotubes. These include difficulties in large scale synthesis, high production cost, limited control over purity and morphology, and incomplete understanding of long term environmental and biological effects. What are the future perspectives of we can say that future research on boron nitride nanotubes is expected to focus on scalable synthesis methods, advanced functionalization strategies, and integration and integration into commercial devices. Interdisciplinary approaches combining materials science, chemistry, physics, and biomedical engineering will be crucial for realizing the full potential of boron nitride nanotubes. What is the conclusion? Conclusion of boron nitride nanotubes. Boron nitride nanotubes represent a unique and high promising class of nanomaterials with exceptional mechanical, thermal, electrical, and chemical properties. Their structural similarity to carbon nanotubes combined with fundamentally different electronic behavior opens new opportunities for applications in extreme environment, advanced composites, electronics, and biomedical. Continued research and technological developments are expected to overcome current challenges and enable the practical utilization of boron nitride nanotubes in next generation technologies. Here are some references from which the material is taken, and here is all about boron nitride nanotubes. Thank you.